9.7 is solving linear and nonlinear systems. So recall when we solved linear systems, we had three methods: substitution, elimination, and graphing. And we're going to use those same three methods in this lesson. Okay, so for number 1, I'm going to try substitution. So if I want to do substitution, I need to get y or x by itself. So I'm going to start by distributing in the top equation. So if I distribute the 3, I get 3y minus 12. If I distribute the negative 2, I get negative 2x plus 6. So next I'll combine the negative 12 and the plus 6. So negative 12 and the plus 6, those make minus 6. And I could add 6 to both sides, or I could just cross these out. Then I'm going to add the 2x to the other side. And now I want to solve for either y or x. It doesn't matter, so I'll just solve for y. Y equals 2/3 x. And so now I take this value and I plug it in for y in the other equation. Don't plug it into the same equation, because then you'll get something like negative 6 equals negative 6. If you plug it into the same equation, the variables will cancel out. Okay, so plugging in 2/3 x for y. Two-thirds x times 2/3 x is 4/9 x squared. Now I'll move up here. So this becomes 5x squared plus 4/9 times 2 is 8/9. And I'm going to move the 53 to the other side. Now I'm going to write 5 as 45 divided by 9. And so now we have common denominators. 45 plus 8 is 53, so we have 53x squared over 9 equals 53. Okay, so now to get rid of 53 over 9, you could multiply by 9 over 53. And if I do that, I have to do that on the other side as well. So the 53's cancel, the 9's cancel. We get x squared equals 9, which means x equals plus or minus 3. Remember, when you square root both sides, you put a plus or minus on the right. And so now we just have to plug in positive 3 and negative 3. So what I'm actually going to do now is right here, I'm going to plug in 9. Because if I plug in 3, x squared is 9. If I plug in negative 3, x squared is still 9. So I'm just going to plug in 9 for x squared. So we get 45 plus 2y squared minus 53 equals 0. So this is 2y squared minus 8 equals 0. 2y squared equals 8, which means y squared equals 4. So y equals plus or minus 2. And now we have to write our final answer as coordinates. So we actually have 4 answers. So 2 possibilities for x, 2 possibilities for y, which means 4 possibilities altogether. They are 3 and 2, so both positive, or both negative, or also 1 positive, 1 negative. So let's keep the 3 positive and make the 2 negative. And now let's switch it, the 3 negative and the 2 positive. So we have 4 answers for number 1. Okay, for number 2, I think we can use elimination. On number 1, we couldn't use elimination because one equation had x squared and y squared. The other equation just had x and y, so we weren't able to eliminate. But on this one, we could eliminate. Looks like it's easiest to eliminate the y's. So if I multiply this by 4, then that would give me 4y squared in the top and negative 4y squared in the bottom. So I'm leaving the first equation alone and multiplying the second equation by 4. Now we combine them together. These will eliminate. We'll get 11x squared equals 44. So x squared equals 4 and x equals plus or minus 2. Okay, so again, I can plug in 2 and negative 2 for x, or I could just plug in 4 for x squared. So if I plug in 4 for x squared, and I'm using the bottom equation, I get 8 minus y squared equals negative 1. Subtract 8 on both sides. Negative y squared equals negative 1 minus 8 is negative 9. Get rid of the negative. Square root both sides. Plus or minus. So here you get y equals plus or minus 3. So again, we have 4 possibilities. They are 2, 3, negative 2, negative 3, 2, negative 3, and negative 2, positive 3. Okay. For number 3, it looks like only one equation has squared variables, so we can't use elimination. We're going to have to go back to substitution. So I'm going to start by solving for y in the second equation, because then all I have to do is divide by 2. So y equals 7 over 2x plus 9. Then take what y equals and plug it into the other equation. So this gives us 5x squared plus 4 times 7 over 2x plus 9 in parentheses. That whole thing gets squared, equals 20. Now we have to FOIL what's in parentheses. 7 over 2x times 7 over 2x is 49 over 4 x squared. 7 over 2x times 9 is 63 over 2x, and we have another one of those. And then 9 times 9 is 81. Okay, now let's distribute the 4. Actually, before we distribute the 4, let's combine the like terms in the middle. So half of 63 plus half of 63 is just 63. And now let's distribute the 4. 49 over 4 times 4 is 49. 63 times 4 is 252. And 81 times 4 is 324. Let's combine the x squares together. 54 x squared plus 252x plus 304. I subtracted the 20 to the left side. And it looks like everything's divisible by 2. 54 is not divisible by 4, so I think all we can do is divide by 2. So 27x squared plus 126x plus 152. All right, is there anything else we could divide by? 3 doesn't go into 152, so 3 doesn't work. 9 also doesn't work. And 27 doesn't work. Okay, so there's nothing else we could divide by. I believe this is factorable, but it's kind of hard to see, so we could do the quadratic formula. Alright, this is good review since we haven't done the quadratic formula in a while. X equals negative b plus or minus the square root. Then I have to take b and square it, minus 4 times a times c all over 2 times a. Okay, so if you grab a calculator, if you do this part on the calculator, you get a negative value. Remember, the part under the radical is called the discriminant, and if the discriminant is negative, then there's no solution or no real solution. So what do we have? We have an ellipse and a line. So imagine an ellipse and a line. How could that have no solution? Well, maybe the line just never intersects with the ellipse. So number 3 has no solution. Alright, so we did elimination and substitution already, and now we're going to try some graphing. Okay, for number 4, looks like we have an ellipse and a parabola. So first I'm going to put the ellipse in standard form by dividing everything by 10, because remember, ellipses have to have 1 on the other side. So divide everything by 10. 5 divided by 10 is the same as x squared over 2. 2y squared over 10 is y squared over 5, which is less than or equal to 1. Alright, then we have, well, let's graph that first. So this is an ellipse centered at 0, 0. Because there's a 2 underneath x squared, we have to go the square root of 2 to the right and to the left. The square root of 2 is about 1.4. Alright, because there's a 5 under y squared, we have to go the square root of 5 up and down. The square root of 5 is a little more than 2. Alright, then I make my ellipse. I'm going to make solid lines because it says less than or equal to. Alright, and less than means shade inside, but I'm going to wait till we graph the parabola first. Okay, for that parabola, I could complete the square, but it would be pointless, because if I completed the square with negative 2, I would get plus 1. So you could say the square is already completed. So now just factor what it said at the beginning. If I factor that, I get x minus 1 squared. So now I can see the vertex. The vertex is at 1, 0. And because the a value is 1, I do the normal pattern, up 1, then up 3, then up 5, and we don't have room to do the up 7. All right, so I use solid lines again because it's less than or equal to. All right, for an ellipse, less than means shade inside. For a parabola, less than means shade below. So we want to be inside the ellipse, but below the parabola. So I'm going to shade only this part of the ellipse. So in the ellipse, but below the parabola. All right, and when your system has two inequalities, it's not like we can list every point that's shaded in. There's infinitely many points in that shaded region. So the solution is our graph with the correct shading. All right, for number 5, that looks like we have a circle for the first equation and an absolute value for the second equation. So this circle, because there are no parentheses with x and y, is centered at 0, 0. And because there's a 49 on the other side, the radius is 7. So we go up, down, left, and right 7. And we make a solid circle because it says less than or equal to. Alright, and now we have to review how to graph an absolute value. So absolute value graphs look like these. So this absolute value graph has a vertex at -1, 0. So we do the opposite of what we see on the inside. And then there's nothing here, so there's a 0 there. So -1, 0. And in front of the absolute value, there's a 1, so it has a slope of 1. So we go up 1 as we go to the right. But because it's absolute value, we also go up 1 as we go to the left. Alright, so we want to be inside the circle, but also above the absolute value. So less than for a circle means inside. Greater than for absolute value means above. So I'm going to shade this part only. The back of the notes is just a guide to help you figure out where to shade. First thing I want to mention, notice on the back everything is a dashed line, and that's because all of the inequalities have either a less than or a greater than. If your problem has a less than or equal to or a greater than or equal to, you're going to make solid lines like we did in the examples in the notes. Okay, so I'll quickly just summarize these. In the top row, we're looking at vertical parabolas. So look at the first and the third figure. Whenever the inequality is less than, you want to shade below the parabola. And if it's greater than, like in the second and fourth picture, you're going to shade above the parabola. Alright, moving on to the second row, we have some horizontal parabolas. So the way to remember these is less than means left. So in the first and the third picture, the symbol is less than and you shade to the left. When it's greater than, you shade to the right. Okay, for the next two rows, for circles and ellipses, whenever it's less than, you're going to shade inside. And when it's greater than, you're going to shade outside. And then finally, for hyperbolas. For hyperbolas, you need to know where the center is. So remember when we graphed the hyperbolas, we always started by putting a dot on the center. So whenever it's less than, you're going to shade where the center is. And whenever it's greater than, you're going to shade where the foci are. And remember, the hyperbolas like to eat the foci. So less than, you shade the center. Greater than, you shade where the foci are on the inside of those double parabolas. Alright, that's it for 9.7, and that's it for the chapter.